Okay, so think about the very heart of your computer or your phone or even the cloud. Deep down inside, there's something called the operating system kernel. It's like the ultimate gatekeeper, right? But what if that gatekeeper had a massive, fatal flaw? Well, today we're going to look at a project that aims to fix exactly that, maybe once and for all.
Let's use an analogy. Imagine your whole digital life is like this giant fortress. The outer walls, they look super strong, totally impenetrable. But what if an attacker finds just one way in, breaches that single outer wall, and suddenly they can go anywhere? They have free reign over the entire castle. That sounds terrifying, right? Well, that's pretty much the reality for most of the computer systems we use every single day.
So that design, that fortress with no internal walls, has a name. It's called a monolithic kernel. And you know what? It's the foundation for, well, almost everything. We're talking Linux, which powers so much of the internet. The entire OS runs as just one single, all-powerful program. Now, don't get me wrong, it's super efficient, which is why we use it. But just like that fortress, a single tiny breach can be absolutely catastrophic.
Okay, so let's dive a little deeper into this huge vulnerability. You could really call it the kernel's Achilles heel.
With a monolithic kernel, you've basically got an all-your-eggs-in-one-basket situation. A single bug, just one tiny crack in any little part of the kernel's code can literally hand an attacker the keys to the entire kingdom. And listen, this isn't some theoretical what-if scenario. This is real. Between 2013 and 2023, the number of reported vulnerabilities in just the Linux kernel, it exploded by over 179%. That's a huge jump.
And here's the part that's really, really alarming. You might think, okay, these bugs are probably in some optional drivers or other random subsystems, right? But just look at this chart. That slice right there labeled kernel, that's almost 6% of all vulnerabilities. And we're not talking about some add-on module. That's the core kernel, the most privileged, most trusted code in the entire system, the king of the castle himself.
So, this all leads to a pretty startling conclusion. And I'm quoting the researchers behind Project Bulkhead here. They say, simply trusting the core kernel is highly questionable. Whoa, think about what that means. It means we've been building our digital walls in the wrong place this whole time. It's not just about protecting things from the kernel. We actually need to protect the system from the kernel itself.
Okay, so you're probably thinking, if this problem is so big and so obvious, why haven't we fixed it already? Well, the truth is, for decades, developers have been caught in this really frustrating trap, a trade-off. For a long time, the choice was just brutal. You could have rock-solid security, but your system would be slow as molasses. Or you could have amazing performance, but you'd be leaving the doors wide open security-wise. People tried things, of course. There were microkernels, which were super secure but had a massive performance penalty. Then there was virtualization, which was also secure, but man, was it complex and a total resource hog. Basically, you just couldn't have your cake and eat it too. And this table here, it really nails the problem. See, these older methods, they usually only gave you what's called one-way isolation. Let's go back to our castle. It's like they could protect a regular room from the king breaking in, but they couldn't protect the royal treasury from a king who's been tricked into opening it. And that exact flaw left them wide open to a really clever kind of attack.
Yeah, it's actually called a confused deputy attack. The name says it all, right? It's like tricking a royal guard, the deputy, into opening the treasury for you. The guard has all the authority, they have the keys, but they're being manipulated into misusing that power. And in the digital world, it's the same thing. If a malicious program can trick the all-powerful kernel, it can literally force the kernel to break its own security rules and just hand over the keys to everyone.
So, how do we get out of this trap? How do we get both security and performance? Well, this brings us to a totally new way of thinking about the problem. It's a project called Bulkhead.
Now, instead of trying to rebuild the entire fortress from scratch, which we know is slow and complicated, Bulkhead does something much smarter. It uses a new hardware feature from Intel to basically install internal walls. You can think of them like invisible force fields put up right inside the existing kernel. It's all about partitioning the fortress we already have, not tearing it down to start over.
So how does this actually work? Well, on a high level, you can think of it as a digital lock and key system that's built right into the computer's hardware. Different parts of the kernel, the core itself, the network drivers, the file system, they each get their own unique hardware key. And then there's this tiny, super efficient little monitor that acts as a gatekeeper. It just makes sure that no part of the kernel can access any memory unless it has the exact right key for that door.
But okay, hold on a second. There's a catch, a big one. This special hardware feature from Intel, it only gives you 16 keys. 16! The Linux kernel has thousands of different modules. So how on earth do you secure thousands of different rooms when you've only got 16 different keys? It seems impossible, right?
And this is where the absolute genius of Bulkhead really shines through. They came up with this brilliant two-level system. So at the first level, they used those 16 hardware keys to create 16 secure zones. But here's the trick. At the second level, they create multiple address spaces, and you can just think of these like separate floors in the castle. Each floor gets its own fresh set of 16 rooms with 16 keys. The system can switch between these floors almost instantly. It's such a simple but powerful idea, and it gives them basically an unlimited number of secure compartments.
And what's so incredible about this design is that it doesn't just solve one problem. It manages to achieve this rare trifecta, this perfect balance of security, performance, and scalability. I mean, that's been the holy grail of kernel design for decades. So let's break down exactly what that means.
So what are these three pillars of Bulkhead? Well, first, you get that strong bidirectional security we talked about. Every single compartment is protected from every other one. Second, it's massively scalable. You can have a virtually unlimited number of these isolated compartments. And third, the third pillar is performance. And this is where things get really interesting.
Yeah, that performance piece, it's the real stunner here. Because normally, when you add this level of security, you expect the system to just slow to a crawl. You expect to pay a heavy price. But Bulkhead is completely different.
Okay, you ready for this? The researchers really put Bulkhead through its paces. They isolated 160 different kernel modules, each in its own little secure box. And the average performance overhead, the slowdown, across a whole bunch of real-world applications was just 2.44%. Let that sink in. 2.44%. That is an insanely low price to pay for this level of security. It's almost nothing. And this is what really shows the magic of its scalability. With the old ways of doing things, the more secure compartments you added, the slower your system would get. The performance would just fall off a cliff. But with Bulkhead, the performance hit is almost flat. You can just keep adding more and more internal walls, and the system barely even notices. That is a total game changer.
Okay, so this is all really cool, nerdy stuff, I get it. But why does this matter? Why should you actually care about the security of something buried so deep inside our computers?
Because a secure kernel is the absolute bedrock of our entire digital life. Think about it. The cloud servers that store your private photos, the work laptop with all your company's sensitive data, the phone that's right there in your pocket, every single one of them depends on the kernel being secure. A breach at that level isn't just a data leak. It's a catastrophic collapse of the whole foundation. Bulkhead is basically a blueprint to fix that foundation once and for all.
And that brings us right back to the beginning, to our fortress. As more and more of our lives are lived inside this digital fortress, the question really isn't just, can we afford for it to have no internal walls? The real question is, how did we ever think that was okay? Project Bulkhead proves we don't have to accept that risk anymore. So the only question left is, how quickly can we start building those walls?